All right. Good morning. Happy Sunday. Pretty early for most people. I've been up for a couple hours now. I am ready to hop back in. Refactoring here. We're refactoring this chess game. And I'm pretty good about it so far. So we have gone through and we have really reduced the complexity that was in our program.cs here. We've done some bad stuff where we currently have some like global variables, which is not great, but you know, we're iterating, where it's an iterative process. We've gone through this file. Used to be 900 lines of code, something like that. We're down to 238, 250-ish. We've pulled out all of the, so let's look at the main method. That's the big one for me. This main method now fits on one screen. Let's close this here. Main method is only 30 lines, 25 lines, something like that. And really, our game loop, this is our game loop. So it's sort of like, this is the setup. I might go through and create a method called setup, and then another method called step or something, where every step in the game is this. So this is our game loop. We've reduced it down to writing a blank line, index select. I can't quite remember. What does index select do? Given a string, turn an array. I don't even know what index select is doing here. It's part of the original code. But essentially we get a piece select, tile select. So select a piece, select a tile, move piece, repeat. That's the game. That's the game. Select a piece, select where you want to move it, loop. And there's some code here that we're not sure if this is actually affecting the game or not. So we've left it in, but we're gonna continue our refactor. Yeah, we had all of the methods for piece logic used to be embedded in this main method. We're slowly pulling things out here. And we are going to continue that process today. So one of the things I want to do this morning, I think it'd be good to start putting, so we have this game state object. I want to start trying to move all of my actual state into this game state and removing it from being public. So I don't necessarily want it to be public. So we're gonna be working on how do we get that sort of into our game state. Yeah, I'm breaking it. These things, so these ones I think deserve to be public. The one thing you might want to be careful about here is these are arrays that can be modified, but we won't modify them. One thing you might do is you might just turn them into strings with the letters 1 through 8, and then string with the columns A through H, and then it's immutable. But I'm okay with it this way as well. Yeah, let's see if we can get this a little bit more cleaned up. Oh, I love how small the logic is for a lot of these things. It used to be, anyway, I'm rambling here. Let's hop in. Let's do some actual refactoring. Let's do some coding here. Let's get some refactoring in. All right. So how do we do that? What do we do next? I'm not 100% sure. Let me get my, just in case someone decides they want to chat with me. Almost never happens. I only have a couple subscribers, and it's early. 6 a.m. where I am, 5 a.m. in California. So in the US, the it might be 8 a.m. somewhere. I guess Sunday morning might be early for some people. Okay, sorry, I'm getting distracted. Okay. My goal, let's come back to my programs. Yes, I want to start putting the actual game state into the game state object. So I have these pieces. They're supposed to be aware of themselves, but they're not. They have their starting position and they move and nothing really happens. So when we actually do a move, I want to update where those pieces are. So let's take a look at that. Essentially, I want to have the game state have like a move method, or the pieces have a move method and they like update themselves. Let's look at it. Let us look at it. Program.cs. So we did a real refactor here for move. Okay. So move takes a selected piece and the target tile, so where they are, where they want to go, and it sort of loops through. It's a string and it finds, I think, let's see if we can look at this again. Select is going to be the symbol. And so we say if the tile is equal to the spot that is the board layout and it's not blank, that piece becomes a dead piece. So if we've moved it into that spot, then we move the selected piece into that spot. Else, if the piece we're selecting is the piece we clear that space out. So it's a little bit interesting that every time we move, we have to look at every space and update it. So it'd be nice. It'll be nice to abstract this, pull this out, and we should be able to just say something like, okay, I want to take this piece and move it to that location. All right, so in my eyepiece, I would like to try, is it eyepiece or do I want to put it in game state? Eyepiece or game state? One of those two places. I think my design's not perfect just yet. But let's put it in game state for now, because game state has access to all the pieces. An individual piece doesn't know where some goes. Let's try putting it in here. Ooh, there's several things I might want to do with games, and I might want to make it so that we can get a list of all the pieces. We could do that. All right, let's come in here. We're gonna do public is empty is. That's fascinating. That's gonna end up not being static later. It's interesting when you come back and you look at some chunk of code. I need to add some comments to this before I get too far. All right, get piece. Given a symbol name for a piece, returns the associated eyepiece. If no such piece is on the board, throw an argument exception. All right, and then try get piece. Yeah. Given a symbol name for a piece, attempt checks if that piece exists in this game state, and sets piece game state. If that piece exists, sets the value of piece and returns true. Otherwise returns false. Okay. I should really learn how I'm supposed to fill these out. I know a lot of people don't fill them out. if you hover over them, now anywhere on, we get this like documentation. If I put something here, big banana, I don't think it actually shows up there. As you are typing out that, so it's sort of when you make the call, as you're typing out that argument, it'll give you that definition. But anyway, the summaries I think is the most important part. Just sort of give a high level description. All right. Is empties fascinating because all it's doing is checking if the position is there. When in reality, we kind of want to have some kind of actual board state thing to keep track of it. So I need to actually have a board state. I need a two-dimensional array to keep track of all these things, or something, or some way to look up where these things are quickly and easily. An array seems to make sense. It's a two-dimensional array. It's a board, so it might make sense to do that and have a bunch of eyepieces or something. Yeah, so I'm just like a little bit torn on what I should on the approach. I would like for my piece to have a move method, but then the piece needs to have a reference to the board, the game state, which might not be horrible, in which case we could get rid of this, like just sort of needs to know. We have to pass it in as part of the construction. I think that might be the correct way to go about it. So, yeah, trying to decide, is empties interesting? Okay, I'm gonna add in a state to this here. I am going to go with I think I want a dictionary. So not all spaces are occupied, so then they'd have to be null. And I want to have, so here are the constraints that I want. I want to have so essentially I want to be able to say, given a row and column on the board, is that position occupied? So that'd be like, this is empty. And I also want, given a position on the board, give me back the piece that's in that position. The way I have it currently set up, I can sort of like iterate through all of my pieces and say, are any of those in that spot, and then return it. I want to do it fast. I want quick lookup times. So an array is probably the way to go. So an array, a two-dimensional array, so private read-only eyepiece like this, and we need to make it, is this how I would do this, equals a board, new eyepiece 8 by 8. So it's saying that maybe eyepiece, the piece could be, the spot could be blank. So if it's null, that means there's nothing in that spot. All right, so then as I build this up, see here, this is what I dislike about this, is now I have to keep track of, there's some state that if I move a piece, I have to update multiple things. I have to update my piece and I have to update my board. And so the question is there, yeah, the question becomes, I guess I can manage that complexity, and I always want to say, can I reduce complexity in some way? But let's keep going here. I may end up hating this, change here. Yeah, I feel like I'm gonna dislike this change, but I kind of want to be able to go both ways. I want to go from, yeah, anyway, so we have 1, 0, so this one's entering 0 to I, so is equal to, no, 1 comma I minus 1 is equal to this. Now an intermediate variable might make sense. Eyepiece, blue pawn. This is now getting, maybe I'm being dumb about it, but I essentially have to do this, where now I need to reference this piece twice and I say, oh, put it in to here and then put it into there. And so maybe I do this. Maybe this is a little nicer. Ooh, I think I can do this. Yeah, there's the ticket. That's what I want. This is a multi-assignment, so I'm saying construct this thing and then put it into, assign it to both of these locations. Someone yell at me if this is a stupid thing to do. I'm trying to keep my code, I think maybe this is a stupid thing to do. I'm trying to keep my code simple, right? So I don't want to get like too long. All right, I think this is bad. I'm doing multiple things per line, right? So I shouldn't do, you should try to do one thing per line of code. Readability is more important than clever code. This is more readable. Possible null reference. I know it's not null because I just assigned it there, so I can get rid of that warning with the exclamation point. Readability is more important than clever code. All right, so that's how we're gonna do it. Did my caps lock get stuck on here? All right, there we go. Okay, so this is what we're gonna do. We're gonna say readability is more important than clever code. Although, I think I wanna make it so that these pieces take in the game state. I think the piece needs to know about the board, and then if I do that, I can always just say in the constructor. Yeah, I think that's what I'm gonna do. That's what I'm gonna do. All right, so I'm gonna make it so, this. All right, this constructor's getting a little long, so I might want to change that, but I'm gonna make my abstract piece take in a game state, and then I'm gonna make this an internal variable. So see, this is why it's ugly. I want to access this state in two different files, and that makes it a little bit, so like object-oriented principle, you want to encapsulate it. Don't let anything outside of the class touch it. So now I have to add like a method that lets me do it. In that method, I really only want these two classes to do it. And so I would do something like internal method, internal void set piece. All right, so it's gonna take in an int row, an int column, and an eyepiece. Okay, and then it would do board at row column is equal to piece. Okay, this would be an internal, saying that like that. So we have this internal method set piece that our abstract class is going to use, and it allows us to set that piece in the board, and it will just override it. So I'm not sure if that's really what we want, or maybe I want to set maybe I want to do this. I want to say, okay, if there's already something there, you can't, and you have to remove it first. All right, so I might do that. I might see if board row column is not equal to null, throw an exception, say like, hey, you can't do that, there's already something there. But when you take a piece, you sort of like overwrite it. So I think, yeah, I'm a little torn. We're gonna go this way and then we'll decide whether or not we like it. Sometimes you have to like program out the whole thing. Diagram out is probably what I should do to think it through. I'm gonna go ahead and do this where I have this internal set and we're gonna only allow our internal code to modify it. So abstract piece. In our constructor, we take a position. We're also gonna take a game state. And we're gonna keep a reference to it. Private read only game state, this dot game state equals game state. So now we have the game state. We can actually remove this from all of our methods now, which is kind of nice. There's some nicety. There's a nicety about that. And then what we do is we say this dot game state dot set piece position. All right, this, and I'm gonna change this actually to take in a pair. That's gonna tell me I don't use it. Unused. All right. What is this? Oh, because I have to do position dot. Waking up. My brain's waking up. Waking code. It's a good way to start your day and get your brain going. All right. Let's keep going here. One sec. What did I do? There we go. All right. This is gonna break, that change is gonna break a lot of stuff, but it's just the constructor. So each of my subclasses here, I'm just gonna take in game state and propagate that through like so. All right, so I can kind of do this. Again, this is where if you had planned this out initially, diagrammed it out, you wouldn't have to refactor, but we're refactoring to go through that process. All right. Rook piece. Put the game state in all of those. And we're gonna wanna access it in our subclass. So I'm actually gonna make it a protected game state like that. So we'll be able to access it in our subclasses. Again, it might make sense to make it internal. I'm not 100% convinced yet, but this will give us access to our game state. So now all of these pieces during construction, we're gonna propagate this game state down to them, and they're gonna add themselves to the board. So my idea is when we move, the piece will move itself. It'll do sort of the, we can create a move method on our abstract piece, and that move method will take care of positioning ourselves on the board. All right, so we're gonna have a move, and that move is gonna say, okay, well, if my logic allows me to do this, I can do it. And it's gonna like throw an exception if you can't, so you have to check. You have to make sure you have a correct move before doing so. Okay, let's make sure we didn't break anything. Do I have that saved? Not for some reason. It always comes back to that. .NET run input to. Should work. I didn't change any logic. I just want well The symbol P1 is not a valid piece on the board. So I did break something. Symbol P1 is not valid piece on the board. This is fascinating. I know. Here we go. I need this. I changed this. Pieces P plus I. Pieces capital P plus I. So I essentially accidentally made it so we didn't spawn any pawns. Okay. There we go. There we go. Okay. Now we have that. We have this. Now I'm gonna go ahead and think I'm gonna commit that. I did quite a bit of changes on the piece. Well, they haven't really done anything. All right, we'll try. We'll make a we're gonna make a move. I think I'm thinking through this as I go. Yeah. So here's what's interesting now is now my get piece can do it off of X, Y. I don't have to do it by symbol anymore. I can say like, oh, get me the piece at position X, Y, or row column, which is like more traditional in chess. You'd say, okay, this is my move. A2 to A4 would be sort of what you would say. You wouldn't say P1. Is that right? Or am I wrong? I'm gonna look this up. Chess move notation. I think maybe I'm wrong. I'm wrong. Someone yell at me. Okay, so the way you do it is you would say, all right, I'm looking, let me get this. I was half right. I was half right. So the notation is the piece, so you'd say queen H4 E1. So it's essentially a combination here. So queen H4 to E1. RD F8. Hang on, let me jump to conclusions very quickly before I start reading. Algebraic notation. Notations for moves. Captures. Okay, so every move is like notated a little bit differently. So that that is tricky. For example, C5, bishop E5. So it's like you put in the piece and you want to the name of the piece followed by where you're going to. Okay, so this notation actually makes a lot of sense. So you don't have to disambiguate. Fascinating, fascinating. Okay. All right. Well, that's all right. Let's keep going. I'm wrong. Laugh at me. I'm incorrect. I don't know enough about chess. I played chess a lot when I was younger in elementary, middle school. I was in a high school chess club for a year or two. And then I got super obsessed with band. I was super into band. All right. Where are we? Yes, I want to make a move. So I want to like get piece. Yeah, public. See, public move, right? So we're gonna have a public move. Oh, I feel like my design is no longer correct, and I'm frustrated by that because our game board, it's almost like our, yeah. Yeah, I feel like I shouldn't be propagating that down, but that's okay. That's okay. So like I feel like I'm violating the principles of encapsulation by giving this down there. But let's add in a method here to allow moving. Public void move. All right, so public void move bool. I'm gonna make it a bool. So it's gonna tell us bool will be true if the move was successful. And so we're gonna take an I piece to move, and then a row and column int row int call target where we want to move that piece. Okay. So given a piece and a target, so set just does it. So we'll try and move piece here. Given a piece and a target, attempt to move that piece there. So we can do the following: if piece dot logic, and we're gonna go piece dot position, so its start position to the target, and then we're gonna give it the game state. So we're gonna rework logic here in a moment. So given those things, if this is the case, we need to move the piece. All right, so moving the piece is taking it out of the previous spot and put it in the new spot. And then we might have captured a piece. So there's like a bunch of logic that we've done previously to capture the piece. So let's make a list, private read only list eyepiece. Ooh, even better. Rather than having a list of captured pieces, I'm gonna add a property. Public bool is captured. So all pieces will tell you whether or not they've been captured. Okay, so we'll be able to set this flag some way. So is captured. We might have a get set. All right, like that. And then in our abstract piece, we'll go ahead and add that guy in there. Public bool is captured. Get set, and by default it's not captured. Okay, let's go back to got a lot of things open. Let's go back to our game state. And we're gonna, if the piece can move there, we want to check and then see if there is a piece there. So board at position target.row comma target.call is captured equals true. So if there was a piece there, we're going to capture it. And we have this cool operator. Oh, I guess I'm wrong. Has to be a variable. Okay. I thought I was cool. I thought I could do this question mark and it would only set it if that were the case. But no, we need to check if this thing has a piece. That's annoying. So I'd have to do a check. So I'd say if, here, I'm gonna do it outside of this check. No, if the logic allows it, that's when we do it. So if the board is not equal to null, so if there's something there, then we're gonna capture it. And we know it's not null, so I can do an exclamation point here. So if it's not null, capture it. All right. Got it. Nested if statements. I always get a little annoyed when I have nested if statements. Is there a way I can get rid of it? That's like my question. It's like, anytime you have an if statement, that's a chance for a bug. Remove if statements if possible. All right, so we're gonna go ahead and mark that piece captured if there was a piece there, and then we update the board. So board target.row target.column is equal to our piece. This is why this is so gross. And then I have to go update like my piece's position. So I'm like, maybe I don't want my piece to know its position. Yeah, it's interesting. Maybe I could do something clever here for it. So if it gets captured, it removes itself from the board. Piece dot move to. This is the other thing I've thought. Move to target. Can I do that? Is that something that would be better? Right. So if I had to move to in my target, it could like update its position and then update the game state. The thing is, I got to keep those two things in sync, and that is annoying to me. But it's like an optimization type thing. All right, I'm rambling here about my choices. I'm torn. I'm torn on how to do it. There's multiple ways I could do it, and I'm torn. So if I can do it, then I'm gonna return true. If I can't do it, I return false. Okay, and I could also just yeah, let's go into my abstract piece. I'm gonna add it into abstract piece. I'm gonna write a move method in here. So let's see how we feel about that. After I've written it, I'll see how I feel about it. It might just feel right. Public bool move int row int call target. All right, so we're gonna move that code there and see how I feel about it. Yeah, so if this dot logic on this dot position target, this dot game state. See how stupid that is now. Okay. So here's what's cool is I might be able to remove these things if I get the move information updating properly. Yeah, so this is okay. I have it. So if I'm allowed to move there, I think I know what I want to do. Then I'm going to do this dot game state dot set piece target this. All right, so I'm going to set the piece there, and then this dot position equals target. Ooh, I think I'm happy. I think I'm gonna be happy. And we return true. It's gonna tell me I'm not allowed to set that, but since I'm in here, I can do this dot underscore position equals target. And I'm gonna do something clever here in a moment. All right, so this is my generic move method. This feels a little bit nicer to me. And then my move method up here becomes this. I just do piece.move. Oh, I gotta add that to my eyepiece. Hang on. Go to eyepiece. Okay. Move target. So this is just like a bypass. So you could do it from the board, say move the piece, or if you have the piece, you can just call move. Actually, if you just have the piece, you could just move it. So this method is dumb to me now, but we have a slightly different method, a better method that says move piece, where we can take in position, int position, int target, like that. And then this, we get the piece that's there. So we do board. Yeah, so we do if board at row column position dot row position dot column is null. So if it's null, we return false. But we know it's not. So if we get past that, we know it's not null. So we're gonna do return board position dot row position dot column dot move target. and we know that it's not null, so we can use the not null indicator operator there at the end, and then call move. All right, so move piece, the board lets us give a row column for our position and our target, and then the piece itself moves itself. And the one piece, someone's yelling, and you see yelling at me right now, going, "Hey, but you just deleted a piece. You might have just lost a piece and that market captured." And so what we do now is in our set piece is where the logic happens. That says, okay, we eventually want to set the piece like this, but we're gonna do board position.row position.column. This is where we do our check. If it's not null here, we're going to mark it captured. Board position.pow position.row position.column dot captured equals true. So if that's the case, we're going to capture it and then update it. So our set piece will mark captured. Maybe not the best design, but I'm kind of okay with it. So we've sort of broken logic into different little chunks here. So our methods are ideally very short, easy to read. Move basically says set my piece, which will mark it as captured. And then this dot position equals target. Maybe I should do the target thing here. I'm not sure. That might make sense. That might make sense to do it here rather than here, because like now you might look at this going like, well, I'm not deleting the piece, and you have to like go into set piece to find it. Yeah, so I'm gonna move it there. We'll keep this as just like a generic set where just overwrites that spot in case our abstract piece needs it. Okay, so I do want to get the piece that's in a location, so I'm gonna do public. I want to try get bool try get piece int row int call position. Okay, and then we're gonna need an out variable, out I piece like that, and then we just do if board at position.row position.column is null, return false. May not have been sent, that's annoying. Return true. Or do I just want to make this return an eyepiece question mark? I'll just do get piece, make it do that. See how I feel about it. So it returns null if nothing's there. Return board at row position.row position.column. And then if it's a one-liner like this, it sort of just can be rewritten to say like that. So let's keep going. So in my abstract piece, I'm going to do eyepiece other is equal to the game state dot get piece at target, and then we just say if I can do it this way now, can't I? No, I can't. If other is not equal to null, other dot is captured equals true. Yeah, that how I want to do it. I think I'll leave that for now. There might be a slightly cleaner way to write this, but I'm okay with this for now. Okay. We're gonna capture it, then we'll set the piece, and then update our position. Okay. So I think I'm okay with that. And then there's like this weird logic I gotta do to keep the game state. So I've written this code here. I'm not sure if it works. So the idea is like this move needs to like update. I'm trying to replace this move, which becomes tricky because I need to maintain some other state here. But yeah, let's see if we can get rid of this. See if we can get rid of this and incorporate what we've done for now into it. So instead of move piece, right? So move piece no longer exists. Instead, I want to get the piece. So I have select an address. So I have select an address. I need to get my piece and figure out where I'm moving it to. So I select in tile. What is tile equal? Is it like, yeah, it's gonna be like A1, something like that. Okay. So I tile select. Rather than returning a string, I kind of want it to return an int now. Okay, so I need, for simplicity's sake for now, oh, do I have ref add here? If it's not, it continues otherwise. So here's interesting. Can I do, I'm about to make too many changes, aren't I? Int zero, not int zero. Ref add 0, ref add 1. Because index tile, that's what index tile goes through, and it pulls out the X and Y given a tile position something. If the board layout is equal to the tile, board layout must, yeah. Board layout contains strings that are the positions of it, so it has labels in there. Fascinating. All right. So we're uncovering as we go. So I have a thing that'll get me my XY positions or my row column, and then we'll pass those back here, and we'll return them up here. So this becomes int target, and no longer have move piece select. Select prompt user returns the selected piece and row column, so it returns the symbol. So in my game state, I'm gonna do game state dot get piece symbol. Yeah. So this is not symbol, but select. That's the symbol of it. And so this is gonna be an eyepiece piece dot move to target. Okay. So now like my model, my game state under the hood is updating, but I need to update this board as well. So I still need to make sure I am having these changes happen as we're slowly getting rid of them outside. All right, so if I've captured a piece, dead pieces still needs to have it. My board layout changes.board layout still needs to contain like specific things, so I'm trying to manage that. So in my abstract piece here, if I've captured something, I need to add that. hit undo. What did I undo? Okay. I need to take this. And my changes, program.changes.deadpieces.add. The piece I'm adding is other, I believe it's other.symbol. So my capture piece. Previously, changes.board at IJ had the piece that I was capturing, but now I can do other.symbol. 90% sure. And then I was also, the board layout needs to get updated like this to my new piece. So my goal is eventually I'm going to remove all of these static things. So when I do a set piece, it's interesting. I'm gonna add it here. I was gonna add it in set piece, but that scares me a little bit. Program.changes at target.row, target.column is equal to this dot symbol. So it's the internal symbol for this piece. And then the where I previous one needs to be a blank. So in my abstract piece, where I update my position, program.changes this dot position dot row, this dot position dot column. What is, oh, position doesn't have, when I do that, it's gonna yell at me saying that in my eyepiece, I think it needs to match. Let's go to my eyepiece. Eyepiece. Row. Column. Did that make my error go away? It did. Okay, so add labels to those. And then my move. My other symbol, my board. All right. This was a lot. This was a lot. Let's try it manually. Well, let's do this first, and then we'll probably do manually, because there's probably... Ooh, I'm amazed that it's working. It seems to... Okay, not working. Not working. So let's see. Let's run the manual version. I did a lot of changes in this file. So I hope I'm able to like revert my program.cs and it'll be okay. And I don't have to go too far back. I'm gonna be really sad if I have to go way back to get to a working state. All right, let's try .NET P1 to A4. Seems to work. I'm assuming there's some issue with capturing. That's the so let's try P2 to B5, P1 to B5. That kind of worked. This now it's like, okay, well, what's my actual bug? Now it becomes really hard. P3 to C6, P1 to C6, P4 to C6. Okay. Don't know what the bug is. I was hoping that would give me some indication of what was going wrong, because my captured pieces are showing up nicely. Alright, let's see if I can revert just my program.cs and things go back to the way they once were. Get status Git reset. I want to do hard because I'm not sure. All right, git checkout program.cs. All right, so this will revert it to the previous change. So program.cs has no changes on it now. Please work. Okay. All right. So reverting that didn't break anything. So I'm going to do a commit on what I have here. Git add. Well, maybe I shouldn't commit because it's not working. Well, the program's working, but my logic and my other spots are not working. I'm not sure. Why not? Okay, I could try something here. Try. I need to isolate. I need to identify where the error happens. Instead of move piece, I want to call move on my pieces. Okay. What's interesting is, oh, I'm never calling move. It's like, shouldn't my board be breaking now too? Part of me thinks the way I'm selecting pieces, so selecting pieces is based off of what's on the board. So I get piece takes that. I can look up my piece by the symbol. Okay, so I can go to my piece via the symbol. And then my address gets updated to wherever that piece is. Piece select turns to select a row and column. Yeah, so string address. How do I get that? Let's look at what this is doing. Returns a selected piece and the row column of that piece. My address. Okay, so I do an index select. And that loops through until it finds it. And then returns the array. So it loops through everything, finds it. So fun little optimization, I could actually return my array here. So as soon as you find it, just return it. And probably throw an exception if you don't, but we're not gonna deal with that right now. Okay. Something's wrong here. When I move my piece, if the place I want to move from doesn't have anything, we return false. Otherwise, we try and move it to the target. Okay, so let's go to my program. I'm trying to do the following. So index select. So this would be, all right. So if I'm correct, we have int start position is equal to address 0, address 1. Okay. And then my target position gets updated here. So this is why this is so interesting. P select equals address. Oh no, it's if the tile equals back, we do a P select. So it's possible that address changes here, and we. All right, hang on. Let's. So leave this. At this point, we have our start position, and then move piece. This is the tile we want to go to. All right, so I need to convert this tile. Where is tile being used here? Tile is equal to the board layout at I. Okay, so I just wasn't converting previously my tile. I wasn't converting it properly. All right, so I need to have something that like tells me int target position equals get position get. I think they do. We have a tile select? No. Tile select actually just gets us a string of where we want to go, and ref add. Oh, I'm so confused. Index tile. Alright, so let's figure out what each of these variables actually means here. Let me. So when I type in a tile, I'm 90% sure. All right, I'm just gonna add a print statement here. Console write line tile. I want to know what tile is here, and then console.readline to pause. .NET run. Okay, so when I select, so I'm going to select P1, and when I move to A4, yeah, prints out A4. All right, so tile, and I was pretty sure that was the case. So tile is the letter digit. So I need to, I'm gonna write just a function that converts letter digit. So int target position is equal to get or board position to index and tile. All right. Private static int board position to index string tile. All right. So the first index. So I have a. So strings columns equals A, B, C, D, E, F, G, H. So the H didn't go to I. I think H is all of them. Yeah, H. I'm gonna do string rows equals 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then basically I'm gonna do a little thing here that I do rows dot index of tile of the second character. So return the row I'm in is this one, and the column I'm in, columns dot index of tile 0. So we're gonna find the index of the first of the letter A, B, C, D, all the way to the end, and then find the row that's 1, 2, 3, 4, 5. All right, so this should get me my row column, my target position, and now I should be able to do game state dot move piece start position target position. Okay. I think I was not correctly selecting my target position before, maybe. I'm not sure. Let's see. Moment of truth, right? No, something's gone wrong here. There's something breaking when we do this with one of our pieces. It makes me a little bit sad to watch it fail in this way. And it's failing when I get to the end of my input, so it's not failing in a nice way. It's a huge bummer. Huge bummer. Can I? All right. All right. See if we can move piece here. So I'm gonna try modifying this to make sure my logic is working. So we'll still do move piece like this. So move piece, I should no longer have to loop through everything to find it because I have my tile select and my, yeah. All right, so I'm gonna try writing a move piece, private static void move piece that's gonna take in a row, column, start, an int row, column, target. See if I can write this so we don't have to loop through and find it. So essentially we want to say these things here. It says if the board layout at target dot row target dot column is not blank, we're gonna add that to our, I'm gonna add that to the dead pieces, and then we are gonna do target.row target.column is equal to the piece that was at the start, which should be this thing, target start.row start.column, and then this gets set to blank. Alright, so the idea is, can I use this move piece instead, which is what I'm trying to do with the move, my internal move inside my logic. So this becomes start position, target position. Does this work? Okay, so that my idea works, is that I don't have to do this loop to get everything. Let's move this comment down here. What's frustrating is my backing stuff is not being updated properly, it would appear. So in my game state, there's a bug. My game state. So I could do something like move this here. And that would take care of it for me. My position.row position.column is equal to null. Turn false. Otherwise move. And move is supposed to... Alright, let's remove all of my program dots in here. It's supposed to be updating those chunks. Let's see here. So there's three. There are three things that need to get modified. If it's dead, we update that. This is why I don't know why this isn't working. Let's stop position to target. If the other is not null, it gets captured, and we should add it to dead pieces. I think that's what I had there though. So those are like the three things. Ooh, maybe a this dot symbol is wrong. That would be interesting. That would be interesting. Be an easy, weird, easy mistake to make. N1, N1, N2, N2, B1. I'm like flailing here. I want to be able to reproduce this error. So it should have the same side effects. I'm just slightly lost here. So there's some move it's not letting me make. Could be one of the move piece. Okay, so now I can. All right, so the idea is, can I get this to call my game state? So game state dot move piece start target. That's what I want. And I want the side effects to be the same. I'm wondering, can I do this? If it's ever not, console dot right line could not move piece. Console dot and then pause. So I wanna, if I go to move a piece, I want it to pause. So it's possible that there's some move that should happen that's not happening. Let's try this. Need like better error messages. No, that was not helpful. So all the times I call move, it does work. Let's slow it down. Let's see if I can spot a bug. All right. If we get to a spot where the board just starts not moving. Somehow related to P1. Here we go. We get to this state, something happens. Am I trying to move my bishop? My B1 got stuck. Now for some reason I keep picking somehow I'm picking P1 or capital P1. It's not letting me move it. Right, so something is going on right there. Let me clear out. I have temp inputs. All right, so if I delete this out, it should record my moves again, and I'm hoping I can, sorry, let's speed it up a little bit. And then I'm hoping I can stop my program right when I can identify where the issue is. So it's right after B1, yeah. Okay. There was some kind of back thing that happened. All right, so there's an issue here that I'm hoping I can reproduce. So yeah, something interesting is going on because it keeps what a tricky one to reproduce, because it's sort of okay. Well, I'm trying to select pieces that K1 lowercase b2, or maybe this is just like not actually even close. It's related to this back somehow. K1 C3, I did that, and then capital P1. Oh, P1 is trying to like move past, but lowercase p1 has not been captured. Interesting. Because this is where, yeah, so P1's supposed to go to A4 and then A3. All right, so P1 to A4 and then lowercase p2 to C7. All right, I remember this. So like P1's trying to make it here. I was checking if it would get if the logic for like turning a pawn into a queen happened. Yeah, so something just isn't right with my move logic, which is sad because that's essentially what I've spent all my time on right now. But sometimes that happens. Sometimes that happens. Okay. What we could do, something I could try, is rather than using this board, use the loop that finds where everything is and detects things that way. I'm a little disheartened right now. It's not logic. It's almost like the piece fascinating. I wish I could identify exactly where things go wrong. I'm gonna try my thing where I take my outputs and I try and identify the first difference between the two. Okay, so I'm gonna put it to 0. And this is my working solution here. And I'm gonna see if I can do output to working to.txt. All right, so that's the one that works. And this is the one that doesn't work. So call this broken. We're gonna see if we can look at those two and see where the differences sort of start occurring. So I have working and I have broken. Let's get those side by side. So if we can hopefully figure out what's going on working, broken, and zoom out a little bit so I can see them both side by side. Let's start there. It's blue's turn. We did it clear, and then we move stuff. Alright, so outputs that, same so far. What are my inputs? This is fascinating. Input 2. P1 to A3. Alright, so I should select. It's interesting looking at this output here. So it's blue's turn. Select piece to move. It shows those moves, and then I'm gonna select selected P1, pick a tile to move or type back. And I'm gonna move to A3. Alright, so this should get me to line 177. That matched. Alright, so then it's green's turn. Let's get to the next move here. Selected capital P1. And line 462. These do match for quite some time. 462. Okay, so I'm gonna run a diff on the two and see if I can find the first difference. So diff, working, broken. And I want to find the first one. One is clear. Diff.txt, so I can just look at that. Diff. Really? Saying the first difference is already on line. I think it's saying line 55. Wow. That's interesting. You know, that I think just has to do with like the text file or something. I'm gonna take that out. All right, this might have been the whole issue before with setting cursor positions and stuff. I'm gonna see if I take this out if there are actually differences. All right, let's try again. Let's go back to my program. Sorry, the font's tiny now. I'm just trying to work through this. Sorry, I didn't want to do that. So this one is the working version. All right, so we'll go to working. And then we'll come here. We'll do to broken. Okay, and then we'll do a diff. Fascinating. All right, so we actually start getting differences. Oh, list of captured pieces isn't updating properly. Okay, that is almost certainly it. Let's look at this. So we got working line 1074. Go to 174. Go to 174. So we look at the previous list of captured pieces, P1. Still see it on the board. So yeah. P1 shouldn't be displayed as captured yet because we didn't actually take it yet. We selected R1 like that, and then moved it here, and then it was listed as taken. Oh, because my positioning must be wrong. So R1, it's off by like 1 or something. Okay, let's go. Take a look at my move piece. I'll bring this back. Increase that size again. Alright, so there's something wrong with my positioning program abstract piece. If there's something in the target. Alright, so my target, I guess maybe I need to print out my target. Get piece, given a row and column. Get the thing in the board there. Fascinating. I'm fascinated here. Alright, so let's go to my program. And let's add in a console.writeLine move. And we're gonna do start to target. And then we're gonna rerun these. We're trying to figure out what's going on. And in my utils, I want to capture what my read line output. So whenever I read a line, I'm gonna write line input. Let's see. Read line. Fonts.readline. And then append my input. I guess I'm confused. Oh, this is me writing to my temp inputs. I want to also output whatever I entered here, so I know what was being typed in. Right line input. Okay, I thought I was doing that here. That's why I was confused. So I'm gonna right line my input as well, so I can see it when it's reading the file. And I'll comment that out again or remove it after the fact. Okay, so I need to go. Am I on working or broken version? This is why unit testing is just superior, because now I'm doing like weird things to test this. All right, so this one is the working version. Working. Supposedly, I should probably run it again just to make sure. This is the broken version. And then let's do the diff of those, and then I'll zoom out again. I'm gonna look at them side by side. Let's look at the diff first. 1091. Working and broken. 1091. Okay, so now that I'm getting my outputs will be printed in here too. So go to line 1091. Okay, so I can sort of look at what it's saying my moves were. Yeah, so 0 0, row 0, column 0 to 0 to 1 0. And it's some reason. All right, so we want to look at when we moved P1, what was the position set to? So it's like the very first thing we do though. So P1, so this is like what I want to look for. Select piece to move. I do regular X with P1. All right. So interesting. So I only do that early on. I move it to that position. Okay, so check this out. This is interesting. I'm moving 1 0 to 2 1 or to 2 0. That's correct. 1 0 to 2 0. But for some reason the piece, the position in my board is not correct. All right, let us move this back over here. Where is my abstract piece? Still having an issue. When something is captured, GameState.set piece. Oh. Row column piece. Seems fine. This dot position is equal to target. Do I ever use this dot position? I do here. Updating the screen, my captured pieces are wrong. This game get piece at target. For some reason, the logic allows me to go my position to target, and it moves properly, but this .GameState.get piece is the wrong thing. I need to, all right, I need to observe what this is. All right, so I know I want to see comment that out for a second. When I move my P1, I want to observe what is in my board, my game state. So after I move P1, I want to check. So each time I move a piece, position to target, I want to print out, okay, console dot right line board at bool result return result. So before we move, board at. So what's the result of doing this? Position.row, position.column. From position. Well, I want to ask, what is the, all right, so the piece that was there. This is. All right, this is what I want to do. Piece console.writeLine was at piece.position. Is now at, so it should match the to and the from. All right, let's try this manual. All right, so we're gonna do P1 to A3. Gotta slow that down a little bit. Console.readline. To pause there. So trying to debug this here. P1 to A3. 1 0 to 2 0 was at 1 0, now at 2 0. So that is updating properly. So what the heck is going on? All right, I'm gonna try moving R1 to there and see if. So I'm trying to build a test case here that will reproduce my problem. So R1 goes to A2. Okay, so all right. So I can reproduce my error right away. So I end up with a piece captured. I know what's going on. I'm not removing when I set a piece. Okay, found my bug. When I move a piece, I need to clear out the previous spot where it was. So after moving, okay, I'm just not deleting the piece. I need to set that previous spot to null. So I need like a remove piece. So when I move a piece from row to column, the board from this spot needs to get cleared. So the piece is occupying 2 spaces. So I was failing at keeping my board in sync. All right. Bad bug. Okay. So here we go. Result equals piece.move, and then in my abstract piece in this move, I need to, so I was setting the target, but I was sitting here, I wasn't doing this with my actual, yeah. So I need to set so I need to have something called like clear piece, like this, which will take a piece and remove it. This is why it's a little bit annoying. Okay, so let's add a clear piece. And this will set this to null. So that is, I believe, what was missing. Okay. Stupid little bug. Alright, let's play it out here. Oh, that wasn't it. That wasn't it. Really? Excuse me. I'm slightly amazed that that did not Did not fix it. Excuse me. So it's supposed to be a simple refactor. But I did write way too much code all at once. All right, clear piece at not target, my original position, this dot position. There we go. Okay. All right, I have some confidence that this is now working. Let's go back to my program. Let's take out program. This. And we can actually just get rid of this whole move piece. And down here, this becomes GameState.move piece. Okay. Feel a lot better at this point. So we got this working, and our test seems to be working. All right, so here's the other thing. I think I just figured out how to do with the diff thing that I've been wanting to do this whole time to verify. I'm not 100% sure, but let's do this to like output one.txt. And then can I make my tests that I was trying to write way at the beginning work? All right. So like the setting the const position, I think just had to do with the size of a file. So by not outputting those, can I make this output test work? So let's run bash test outputs. Interesting. Oh, because I did output too. Oh, here we go. So this should be give me nothing. All right, then let's break something real quick. Let's go into my program, and we'll do a console.writeLine moved. So what we're doing is we're testing that the output is identical to what we did initially. So my bash test output should yell at me saying that there's differences now. Yeah. Okay. So I think we'll find out soon whether or not this works. It doesn't. What? I just. This just doesn't make sense to me. Did I do something wrong here? I just can't spend more time on this. This is. I spent 2 hours on that before. Is output 2 changing? What the heck? Did I not hit save? So it works fine there. It deletes it, right? It's not deleting it, something. Just ran them twice in a row and it still gives me what they're different. And I made no changes. I just don't understand. I don't understand. It has to do with the cursor changing positions or something. That's okay. All right, I have this. I was able to get rid of the move. The move method, move it into my pieces. My pieces are tracking, seem to be properly keeping track of the state. So get status, get add. I did a bunch. I don't need diff or broken or working. Remove broken, remove diff, remove working, git add everything, git commit, refactor, add move to abstract piece, remove the move piece method from program, and add state to game state to track piece locations. All right, so got that changing. Whew. That was way harder than I wanted it to be. So let's come in here. Let's add in some comments. Should have added these before I committed. Let's add in some comments here. So moves the piece, moves a piece from POS to target, returns true if the piece was moved, and false otherwise. I should be able to just do return piece.move again. This can be like that. Make sure I didn't break anything. Whew. That hurt. That hurt my brain. Okay. Get rid of these because I'm not using them. Get piece. Given a position, returns the piece on the board, or null if no piece is at that location. Okay. Is empty. All right, so this is something I wanted to be able to do for a while. Returns true if no piece is at the specified position, otherwise false. All right, so now this should not be static. This becomes return board at row position.row, position.column is null. And then let's go fix abstract piece. Where was I using that? Yeah. This becomes game state.isEmpty. Okay, so now I can actually start removing. I can change my interface so that my pieces know how to move themselves on the board since game state's built in. So let's do that. Let's go to iPiece. All these things where I'm passing in game state. Is that true? Yeah, let's get rid of that. And I think we can all start getting rid of the starting position on them as well. So let's do that in a moment. Let's go through and fix all of the. We got to fix all the logics and all the methods in abstract piece. So logic no longer takes that. We're gonna get rid of it in sub logic as well. And this becomes this dot game state. This dot is enemy piece. Should still work. This goes away. Is enemy piece no longer needs game state because it's going to be this dot game state. This dot logic doesn't use that anymore. get moves no longer has game state being propagated down into it. This whole thing needs to get rewritten now to use. And so we're slowly getting rid of our global variables. Slowly getting rid of them. This just becomes logic. We're happy there, and then in all of our subclasses, we got to get rid of this game state. Didn't even need it on that one because we're using global. All right. So as we slowly get rid of global stuff, it'll become much more apparent, but we'll be able to swap it out for our local game state. What did I miss? No, just too fast for the compiler. Let's see if we broke everything. Hopefully not. We did break some stuff. Let's see, get moves no longer takes in a game state. And logic no longer takes in a game state. Okay. Fingers crossed, we broke it all. All right, nothing was happening there. All right. Oh man. Did a lot of changes. All right, let's see if we can figure out what went wrong. Let's do .NET run. I know the first move is P1. All right, so I can't move anything anymore is what happened. All right, so let's look at our broke the logics is essentially what's happening here. Took out game state. Abstract piece. Where's the base logic? Fascinating. Took too many of them out all at once. All right, let's I had written some comments that I should have committed in the previous commit. Where did I add those? Not here, not in game state. I think they were in. I think they were here. All right, let's undo. This was static before. Okay, let's just get reset hard. You work still. Nope. All right, go back to where it wasn't broken, and then try not to break it. All right, let's do this one first. Is empty. It is empty if our board at position.row, position.column is null. All right, let's do just that one and fix it. This dot game state. One step at a time. All right. Wouldn't be surprised if that's where everything went wrong. All right, so now logic can lose game state, and we can go to where it's defined. Go to, isn't there an option to hop to my superclass? All right, that's fine. These become this dot game state. I got excited, changed too much code all at once. All right. So my eyepiece now logic is this. Oh, that's not logic. Logic. Okay. Get rid of my logic. What are my errors? So logic no longer takes this. and logic no longer takes this. And I think there was one spot in program where logic no longer takes that. Okay, let's try it. Okay, didn't break it. Didn't break it yet. Glad I have a test. I'd be really sad if I didn't have a test to automate. I'd have to manually go through and do some of these things. Okay, let's keep going. I was in eyepiece. Eyepiece, I got rid of that. My goal is to get rid of game state being referenced here. So we're gonna drop it from get moves. Okay, so an abstract piece, I no longer have get moves. Or so with game state there. And I think that also is true in my program. All right, let's run the test. All right, I'm feeling pretty confident about that. Press forward. All right, now I want to get rid of my sub logic. My sub logic game state. Okay. Sub logic. Actually, before I do that, let's get rid of it in is enemy piece. See if that's in a lot of places. This dot game state. Is it anywhere else? That might have been it. Yeah, I think that was it. Some really simple refactors now. Get rid of it in sub logic, which is gonna force me. So this is the big one where I'm coming through. Remove it from each one of these. I think what happened, and we'll find out in a moment, is my refactor to like is enemy I did wrong, and so it just broke everything. It's just fascinating that these, well, not fascinating, these don't use game state, but it's because they're using like this thing. So the next step is going to make it so that these are using game state, and then I should hopefully be able to get rid of that global variable. All right. Did I get them all? Okay, I got them all. All right, I'm assuming if I went back and looked at the video of what I had done, if I went to game state, I'm pretty sure I did something wrong here with is empty. Let's add these comments back in. Given two moves the piece at POS to target attempts to move. If a piece was moved, returns true, otherwise returns false. Get piece returns the piece at the specified position, or null if no piece is at that position. Is empty returns true if there is no piece at the specified position, and false otherwise. Okay. Don't think my comments could break anything, but you know, I am a terrible programmer, so I'm running it anyway. All right, I have some confidence that things are still working. Git commit -m refactor. What did I do? Remove reference to game state in param list. In that's it. That's essentially it. Okay. Let's do that. Whew, been going 2 hours. Made much less progress than I'd hoped to, but let's keep going. I'm gonna keep pushing. Keep pushing here. I have this set up to where now I have my board state inside of my game state. So in my sublogics, I want to be able to ask questions about my game state rather than my like the board logic, right? So now I can actually start getting my sublogics and refactoring those, reducing those. Okay. Let us come in here and look at some of the easy pieces. So king piece. King piece need any refactoring? It doesn't. There's nothing in the king piece that refers to global state. Bishop piece. There is some global state being used here, so let's see if we can get rid of this. So we got to figure out what it's asking. Okay. If changes.pieces contains the piece at ij and ij is not equal to where we're going, return false. Trying to understand what this logic is saying here. So I think program.changes.pieces. Let's go look at how this is pieces. Where is this used? Excuse me. In our program, where do we add stuff to this? Oh, interesting. It looks like in our layout, we have this list here. So let's look at the different spots where we actually do pieces.add. Okay, so pieces, I hate that it's public in this way, because you could just have add anywhere. But it looks like we're adding things and nothing ever gets removed. This is so peculiar to me, and I'm trying to understand why we're doing this. Okay, so when we initialize a print board, we add. Okay, so this is just saying how we've added the pieces to the board. So shouldn't all, let's go look at changes. It's read only, so changes never changes. Changes.piece is .remove .add. I think the only place. Oh, cancel that. What is going on here? So in print board, pieces.add, we add our pieces, we never remove anything. So won't this, okay, so we're saying get if the board layout ij is a piece. Okay, so because we have a lot of blanks in there, so we're actually saying if we're looping. All right, so this is looping through this logic here in the bishop piece is looping through diagonally positions away from the center, I believe. So we have an int I equals start row, j equals start column. And then we say if j is greater than 0, while j is greater than 0 and less than 2, while I is greater than 0 and less than, sorry, 7, greater than, so while these are within our bounds, I'm pretty sure this is just getting all of the positions on the board where we can move sublogic. Yeah, sublogic from start to target. Oh, okay. So this is actually just check. So here, this is what's really interesting. This is just checking to see. Is that right? Checking to see. So we're going diagonal between the start and end position. It's trying to determine whether or not there's something in between us. Okay, so it's checking. So this is getting all of the positions between start and target. It's making sure that it's diagonal. So make sure it's diagonal. And then it also, so I think we can rewrite this logic a little bit. So bishop logic can only move diagonally, right? So that's what this one's saying. It's saying my start row minus my target row needs to be equal to my start column minus my target column. So it's saying the number of places I move to the left needs to be the same I move up or down. So if that's not the case, I return false. All right, so this is can only move diagonally. Next, this thing here is checking bishop cannot move through a piece. Okay, so it's essentially saying, all right, loop through in the direction between all of these things. So what would be really helpful is to have something that says get all of the positions between these two. And so that's essentially what we're doing here. So we're saying if I made it to my target, if I is equal to target, we break and return true. So it's interesting, we could probably just return true here. So if I've reached my target, if my row is greater than, if my start row is greater than my target row, I'm going down, so I decrease, so I is going up and to the left, otherwise I increase. All right, so I'm gonna do a little bit here. I'm gonna say I is equal to start row greater than target row. I minus I minus 1, I plus 1. So this is what that is doing here. And I'm gonna create a little Boolean. Go up is equal to this. All right, so go up is saying if my start row is greater than my target row, I should go up. And then bool go right is going to be equal to my start column, or this is actually going to be go left. All right, so then my j is equal to, if I go left, j minus 1, otherwise j plus 1. So if I go, that's this chunk here. All right, let's test this out. See if everything still works out. Cool. I'm happy with that. And then, so this is just iterating through all my positions on my board between those two. So I actually want to do the following. I kind of want to say, okay, loop through these are my IJ possibilities. I actually don't think we care that much about this. We just want to. All right, so so I'm gonna do a while. Is that right? So we start at those things, and then this is sort of our afterthought. We can put this here. I'm gonna leave it inside my loop because it's a little bit confusing up there. Took out too much. Really just want to go between the two. Okay, so I want to get all of my positions. And this thing is gonna break for us, right? So I'm gonna do a thing here, a list of eyepiece pieces. It's new, and I'm probably gonna find that I can get rid of this as well. But how I'm iterating is important. This is why I was saying like this might be like some kind of while loop. I'm gonna rename this for my brain. I'm gonna do row and column. I and J are fine, but row and column just make a little bit more sense to me. It's row equals start dot row and column equals start dot column, and we essentially have like this while true happening here. So for semicolon semicolon is the same as while true, and we're just gonna loop until we have this. So we actually want to loop well, this is we were gonna end. We want to loop until this condition, right? So in fact we can say loop well row is not equal to target row, or column is not equal to target column. And the cool thing is we know that when this is like they're both gonna get set at the same time. So I get rid of this if here, and then this is sort of how I increase or decrease. Okay, and then really what I'm checking is say if there's something in the board that's in the spot, then I return false. All right, so if this dot game state dot is empty at row column, so if it's not empty, I return false. All right, let's try it. I think this is it. So we loop through all my positions, and then if one of those spots is not empty, I return false. Let's try it. I'm sure I broke something, but maybe I got lucky. Yeah, I broke something. And that's why we have a test. That's why we have a test. Okay, so where am I going wrong is sort of important to check here. So I should be able to do, let me slow my program down. I should be able to come in and check it out. All right, so I want to move a bishop. Let me do P2 to, what is that, B4. Let's move P4 to D5, B1 to A3, B1. Seems okay-ish at a glance. To D7. Let's try B1 again. Let's move it to B2, capital B1. I'm trying to find where my sort of oh, is Here, let's see if I can take a piece with it. Let's move it to G4. B1. Yeah. Yeah. So I cannot. So that's my bug here. When the final location at the final location is if there is a piece at the position I'm trying to go to, then I can move there because I'm going to take that piece, as long as that piece is not an enemy piece, but that's covered by the generic logic. So it only lets me take enemy pieces. So this is slightly wrong in that we need -1. Okay, so if it's -1, we're good. Because the last piece, it's like, oh, if there's a piece there, I'm okay, I can take it. So let's try that. Oh, let's turn that delay down to nothing. Speed through it. Nope, I'm wrong. I'm wrong. Thought I was right, but I'm not. All right, let's try again. P4 to D5 to D4 and P5 to E5 and B1. No, I can't move it at all. What did I do? All right, so I've done something terribly wrong. I don't need this list of pieces. So that's gonna add all the pieces from my board into it. That last piece. Well, it's not equal to my target row, my target column. It's empty. Oh, what's nice is I have something better I can do. We'll go row, increment, column, increment. So if this is the case, we're gonna -1 + 1, -1 + 1, and then this becomes plus equal row inc plus equals column inc. I want to check this first. So we don't want to start in our row column that we're at. We want to start in the spot in the diagonal that we're moving. Then we loop through. If it's empty, if it's not empty, we're false. Otherwise, we keep going. All right, so we're gonna try and find the piece. All right. There we go. There we go. I don't need this list. What I was gonna do is I'm gonna say, build my list up of all the pieces that are between me, and then if that list is not empty, return false. But this works. This is what we're doing here. So I don't need the list. I can just check every position as I go. All right. So this is my new bishop logic that doesn't use my global state. So let us add in this commit. Git commit -mv or refactor bishop piece to use game state. Okay, next piece. So that was our bishop. Our king piece doesn't use the game state, I don't think. Yeah, it just sort of says go into my adjacent spot. So this is cool. Can we make this logic a little bit better? Or not better, simpler. So essentially what we're saying is, am I picking a spot that's next to the king, right? So is my distance from where I started at most 1? And I'm wondering if there's a nice way to do this. And I think we can say that, I think we can use like triangulate. This might just make more sense, I'm not sure, but let me see if I can simplify this. I'm gonna try and simplify my king logic here rather than have all of my ifs like this. So this is saying equal, they like have to equal 1, but I kind of want to take like the distance or something. All right, I think I can do a little bit better than this if else branch. Remember my, I always tell my students, if statements cause bugs. If statements are spots where bugs happen, so fewer if statements is better, typically. So I'm gonna see here, I want to get all of this adjacent spaces from start. And if target is one of those adjacent spaces, then we're good, right? Can I do that in an easy way? Yeah, so my greatest distance should be diagonally 2, so like the distance, yeah, so I'm gonna say the absolute, so we can't move into the space that we're in, so we're gonna say start and target cannot. So I think I found a another one. We say that start and target can't be the same, so cannot take pieces of the same color, cannot capture. If start is equal to target, return false. Pieces cannot move onto themselves. All right, let's make sure that, I know that seems stupid, but it'll be useful for when we do this king thing that I want to do. All right, so what I want to do is so I know the king can't move on to itself. So now I'm gonna say, if my absolute value, I think, all right, so if so int row distance is equal to row start dot row minus target dot row. So this is the distance between the distance in rows. Int column distance is equal to math dot absolute value of column target start dot column minus target dot column. All right, so these are my X and Y, my row and column distances. And so I know that, is it the sum of these? I need to take like the square root. So I want triangle. There's a triangle. If I go diagonal, it's a triangle. So at most, so I have like row distance. Am I making this too complicated? I think I'm just making it too complicated. Am I making it? No. All I do is say, yeah, my distance. So if row distance greater than 1, return false. If column distance greater than 1, return false. Otherwise, I return true. And I've deleted my column distance somehow. All right, I think this is, yeah, so I say, I can't move on to myself. So my generic logic checks that. And then the sub logic is, well, the distance has to be greater than, can't be greater than 1. So I cannot move more than 1 in any direction. Let's test this out. So I don't think I ever tried to move the king incorrectly, so I'll have to manually test it here. But let's make sure that my king, see my king moving. I just got to get into a spot where I can see what positions it allows the king. .NET run. Okay, so let's do P4 to D, and I need to slow my program down because I can actually see it. Program 1000. P4 to D4, P5 to E5, K1, all right, to D2, K1 to E7, K1, pretty, I think we're good, to what would that be? E3, K1 to D6, K1 to F4, King 1 to C5, and then King 1, yeah. All right, so I think we're good there. I like that logic a little bit better. In my mind, it's a little simpler to read than the series of if else's. So we always try and reduce your complexity when possible. And in fact, we can say return. So if we get the row distance and our column distance, this becomes a one round. We say return row dist less than 1, less than or equal to 1, and column dist less than or equal to 1. So if both of those are true, we're true. All right, so the distance of those two have to be less than 1. And I think by pulling them out here, it actually makes the code a little bit more clear than if we put them in there directly. So our row distance has to be less than or equal to 1. Yeah, let's try again. Just real quick to make sure. P4 to D4, P5 to E5, K1. Yeah. And let's do the full input 2. Oh, every time. Always forget to set the delay back to 0. Here we go. All right, I'm happy with that. So we've just refactored the king, get status, get add. First, we're gonna add the abstract piece, get commit -m feat generic piece logic ensures piece. We'll just put this piece cannot take itself. Add logic to generic logic method to prevent a piece from taking itself. So now we don't have to worry about that in our sub logic. All right. So we refactored bishop, we refactored king. Oh, I need to commit my king. Get status, get add piece, get commit -m, refactor, king, simplify, king piece sub logic. Okay, we've done bishop, we've done king. Let's look at the knight. This one's, I think we can do something similar here. We never use player. All right, so with a knight, you have to be that your, well, maybe, all right, I'm gonna abstract these things out here. So we got int, yeah, this one's a little trickier too. Int, this logic might actually be fine. Row dist equals math.absolute start dot row minus target dot row, int column distance equals math start dot column minus row target dot column. All right. I'm gonna say row dist. If row dist is equal to column dist, these are like some to me these are interesting checks because they can't be equivalent. Really, I want the total distance to be 3, right? The total distance needs to be 3, but you need 2 in one direction and 1 in the other. And I'm sure that's like what this logic is doing. So this is our row distance. So our row distance not equal to 1, and our column distance is not equal to 1. So if they're both column distance, row distance. I'm gonna make sure this still works. Give me some confidence that it does at least. All right, my knights still move. So really what I care is they're not the same. And then that, yeah, so if they are the same, we return false. And then one of them needs to be 2 and one of them needs to be 3. Is there a nice little Boolean logic thing we can do there? And I guess I could do row dist is not equal to column dist. So they can't be equal. So they can't be equal, and row dist plus column dist is equal to 3. So the sum must be 3. And one of them has to be equal to 1. So then we say row dist equals 1 or column dist equals 1. That should get it. So we're gonna say they can't be equal. Oh, I actually don't even think I need that. I don't even think I need that. All right, so one of them has to be 1, and then the sum has to equal 3. Yeah, I think I like that. Let's see if we broke it. Probably. I'm not very smart, so this is why I need tests to keep me from breaking everything. All right, it feels pretty good. Let's slow it down and see what spots get highlighted for us. N1. Okay, so to C3, N2 to F6, N1. Okay. All right, I'm pretty happy with that. Pretty happy with that. So I got to refactor, get status, get add. Oh, move this back to 0. My git told me it was modified. Git add all, git commit -m, refactor, night piece logic simplify. Okay, so we simplify the night piece logic like that. I'm happy with it. Pawns have crazy logic, so I'm gonna. Pawns are so interesting because they can move forward twice if they haven't moved yet. All right, so the pawn has to like keep track of has it moved before. So I guess if it's in its start row. All right, so I have a thought on how I'm gonna keep track of that, but yeah, if pawn hasn't moved yet, it can move 2 spaces forward. Otherwise, it can only move 1 piece forward. But then also, if there's a piece diagonally in front of it, it can capture that piece. And then there's a weird a rule called in passing, en passant, which says like in specific positions, the pawn can like move past a piece and take it diagonally. So there's like weird conditions for that. I'm gonna save the pawn for later because I think it's actually like the most complex piece in the game. I think the pawn is the most complex piece in the game. All right, let's go to rook. This rook is an awful lot like our bishop. Okay, so this logic here feels a little tricky to me. Let's do our rook next. Rook. So I'm gonna go ahead and try and do the same thing, the sub logic here. What is? I think this is, all right. There's some interesting stuff going on here. I believe the rook piece, I can get away with just basically saying like, go left or right, up or down. Those are the 2 directions you can move, right? So you can go just up, just left. All right, so I'm just gonna, well, I'm gonna start this from scratch and see if I can get it simpler. This logic looks really, so like figuring out if I should go left or right is here or here. Okay, so we want to determine what, we want to make sure that we can only go orthogonally up and down, left or right. Okay, so our rows have to match or our columns have to match. If a row, so we're gonna say if row start dot row is equal to our target dot row, we're going left and right. Okay, but I think so. In my mind, I want to say, okay, well, which directions am I moving? So I'm gonna come up with int row increment, and so I'm gonna say if my row is equal to my start dot row is equal to my target dot row, I have 0. Otherwise, it's up or down. Yeah. So if my target row is equal to my start row, my row doesn't change, and then otherwise I need to get the difference as the number 1. So then I need to determine up or down. So this I think actually does deserve an if statement. Otherwise, I'm gonna end up with this weird ternary thing going off to right. So I'm gonna say row increments 0 to start, and then if row start dot row. What's the nice way to do this? Maybe I can do something clever here. So it's gonna be 0 if they're the same. Otherwise, it's gonna be something 1. Is there a math function that lets me get the this is gonna be something else, but I'm gonna do that for now. And then I need to multiply it. So row inc I want to know if the distance is positive or negative. So I sort of need to do start.row minus target.row. So I subtract them and I get a difference. This is what we do. Divided by math.absolute value. But if it's 0, yeah. So we do. If it's 0, we don't want to do a division here because it'll blow things up on us. Maybe I shouldn't try and be clever. Maybe, you know, sometimes you don't want to be clever. All right. Well, let's try this. So I'm gonna write all the logic out here. If row increment, if start dot row is equal to target dot row, row increment equals 0. Else if start row is greater than target dot row, row increment equals -1, because our start row's bigger, so we need to move towards our target, so we're going minus. Else row inc equals 1. So our start row is smaller than our target row, so we need to increase as we go down. All right, so I'm just gonna write a helper function here. Private static int get increment int start int target. And this is going to return 0, 1, or -1. So we have, instead of row, we do start and target. And if this is the case, we return 0, return -1, return 1. So now we have a thing here that's going to tell us which direction we need to move in, which direction we need to increment. And now I'm going to do row inc equals get increment on start.row comma target.row. Int column increment is get increment on start column and target column. So notice I was going like, well, this is going to be more complex than I want. I'm going to have a bunch of if statements, so then I have to get all of this. All right. So now I have a condition here that essentially my one, if they're both 0, I have a problem. I've selected my index or where I am. So that shouldn't happen because I'm catching that in my logic piece. So if they both are 0, that means that's an impossible state to get to here if they're both 0. All right, so I know that the sum of these, only one of them should be 1. All right, so if they're both not that, if they're both something that is greater than 1, so if the absolute value of row inc plus the absolute value of column inc is not equal to 1, this move is not allowed. So if the absolute value, right, of row inc and column inc is not equal to 1. So we should have 1 in some direction. Then we can't do it. Otherwise, now we have our incrementer. We can go to our start. All right, so int row equals start dot row plus row inc. Int column equals start dot call plus call inc. And then we do a similar loop where we say, well, can't move through things. So in our bishop piece, we essentially have the logic that we want here. Like this. All right. So while it's not equal to our target row, we check if it's not empty, we can't do it, and we just keep going. All right. So that's the logic there. Notice I've just done a copy paste. That tells me there's some logic, maybe some utility that I could do. This is why I was saying, well, I want to sort of just get all the pieces that are in between me and check whether or not there's something there. So I'm going to end up writing something, but we'll get there in a minute. Let's see if this we'll do this test first. Okay, and then I'm going to do a manual test just to make sure the display seems sane to me. But I'm really quite happy with this refactor here. I think it's a little bit easier to understand. Okay, so we have P1 to A4, P8 to H5, R1 to A3, R2 to H6, R1, let's have it move out and try and capture piece to H3, R2, let's have it move somewhere I can see a little bit better, C6, R1, cool, to H5, R2 to C2. Okay, pretty happy with that. Let's get my program back to no delay. Let's do a commit, get status, get at, what's different? What did get diff, oh, need a 0 here. Get add piece, get commit dash m, refactor, simplify, rook, piece, logic. Okay. And we have queen and pawn left, but we just took this logic here and we copy and pasted this. So remember, don't repeat yourself. We want to do a thing where we don't repeat ourselves. And so I want to write a little helper method for us that lets us check if there are pieces between, given, you know, a start and a target, and check all the pieces between those two things. Okay, so I'm gonna write a static helper method in game state that is going to tell us whether or not there's something in between two positions. So we're going to have public bool check naming is so bad. I'm bad at this. Check or is path clear? And we're gonna go from int row, int call, start, int row, int call, target. So those are the two positions. We're gonna check to see if there's nothing between those two things, and we've essentially written that code here. All right, so I'm gonna sort of copy that over here. We actually don't care that much about the increment difference. So let's still this. So here's the cool thing. I'm gonna be able to just have this as a helper method in game state. I'm gonna make this an internal get increment. So I still want to be able to make sure that I'm only going in one direction on my other stuff. Maybe I don't need it to be internal, but we'll see if I can get away with making it private. Is path clear? All right, so we get our increment, we increase, and then if this is not empty at that spot, then at the end we return true. All right, so now I have my game state, so my rook piece. This is why I think I might need those increments, but because I need to make sure that I'm only moving orthogonal, right? So orthogonal movement. So I still think I want that that there. So I'm gonna make this internal. Get increment. This really might just need to be like in a utils class. I'm gonna move it to a utils class. Utils. Public. Format document. Given two integers. Returns 0 if they are the same, -1 if start is greater than target, and 1 if target is greater than start. It's essentially what it does. Let's format that a little bit. All right, so we have this get increment in my game state. Now I'm going to do utils dot get increment. So I'm using it in multiple places. Utils dot. Okay. And then if I am moving orthogonally, I basically return game state dot this dot game state dot is path clear between my start and my target. That looks really nice to me. Let's see how we do. My test continues to work, so I have some confidence that it is still the same. So I've refactored my rook piece here. I can now also refactor my bishop piece, which is nice. In the same way, right? So my rook piece and my bishop piece here. So if I'm moving diagonally, the sum of these should equal 2, right? So I need to go over 1 and up 1. So the sum of my increments has to be 2 in the case of my bishop. And same thing here. I should be able to now do this logic like this. Is my path clear? Oh no! Index is outside of the array on that one. Interesting. What happened here? Let's see if I can see the bug I've introduced if I manually run this real quick. So I want to get my bishop out, so let's try doing p4 to d4, p5 to e5, b1. Okay, it just crashes when I try and get my pieces. which is interesting. So interesting, a little perturbed. Oh, but I think my generic logic here kind of makes sense. Let's go look at get moves. Get moves is interesting. My list of moves for each string in the board layout. I'm checking if the logic works. My position to my target. I can pull it out. Let's see where my index out of bounds is happening. Game state, line 90. Is empty, row column. And where is that getting called from? Here. Is path clear from my row to my column? So when I'm at the edge of the board. Okay. So row and column must be out of the bounds of the board is what's happening here. Because I've incremented my row and my column. I'm not at my target yet. This is interesting. My increments must be wrong. So I shouldn't be. Interesting. Is path clear? I'm out of bounds. Selected B1. Doesn't tell me what my index was. Index was outside the bounds of the array. In my row dot column. So while my row is not equal to my target row, and while my column is not equal to my target column, check if it's empty. What's interesting is my bishop piece had this sort of logic in it previously. So my get increment must be wrong. Let's try this. Oh. I'll do a regular run, I'll just get there. P4 to E4 to D4, P5 to E5, B1, crash. Okay. Yeah. So the way I'm getting my increment is wrong. So if my start row is greater than my target row, my start row is greater than my target row, I should be -1, otherwise I'm 1. Oh, if I'm not equal, all right, I gotta console dot right line row inc. I gotta figure out. Should probably be putting in some breakpoints, but let's do some print line debugging. Console dot right line start and just so we can see target. See what's going on with that. What's interesting is we check logic on every possible position on the board, which feels overkill. That's okay. It's completely fine way. E4 to D4. P5 to E5, B1. Okay. So we're saying if I start at 0, 2, and my target is 2, 3, my row inc is 1, my column inc is 1 as well. So that 0, 2 is this bishop spot, 0, 0, 1, 2. And I'm trying to go to 2, 3, so that'd be 0, 1, 2, 0, 1, 2, 3. So, what's interesting is my row inc is 1 and my column inc is 1, but that's not right. That's not really what I want. I want to get, they need to be, all right, so this happened to work well with orthogonal because I know that one of them is always one direction. Okay, so this isn't gonna work. I need to, okay, I got it. I know what's going on. I need to make sure that I am diagonal. All right, so I did that. How did I do that before? I need this check in here still, is essentially, can't move diagonal. This check is still unique to my bishop's sublogic. All right, and then now after I've done that check, I know that I'm moving diagonal, so I can get the increment from my start and target positions. Start row. So I know for a fact that this is target.column. All right, so that was, and then once I have, well, in fact, I don't even have to do this anymore. My get increment, I don't need here because I can actually say, okay, well, I know my path is diagonal, and so now I just need to return is path clear. Is path clear between start and target. So if I'm going diagonally, is the path between those two things clear? Let's try it. P4 to D4, P5 to E5, B1. There we go. B1 to, let's move it down to G5. B2, let's move it up to B4, B1. Yeah, and so I can take the queen there, D8. All right. So I just wasn't doing this diagonal check. Now that I know that it is in fact going diagonally, all I can do is check if the path is clear. This is sort of checking orthogonality. And this is checking diagonal. Can only move diagonally. And then this one is can only move orthogonally. Okay, I'm happy. Let's run my bigger test, my longer test, my more robust test here. Then we'll do my queen. I don't think I'm gonna do the pawn today. I've been going for 3 hours, so I'm gonna stop, eat breakfast, and then we'll probably, might come back later. But let's run this, just make sure, give me some confidence that I haven't broken it completely. All right, get status, get add, let's look, get diff, game state. Yeah, so I abstracted that into path is clear. Let's go to game state. Have some extra spaces there that I don't like. And let's add a comment. Given a starting and ending position, I really should have the check here is path clear that checks whether or not it is truly orthogonal or diagonal. So I'm glad I looked at this. Given a starting and ending position, determine that are orthogonal. How do you spell orthogonal? Does my dictionary does not have that word? Orthogonal. Oh, I just said the A and the L reversed. Orthogonal, given a starting position and target position. I should have probably called it end. Given a starting target and target position that are orthogonal or diagonal to each other, returns true if no pieces are found between them, and false otherwise. Okay, so now I'm going to move that orthogonal check into my... I still need to make sure that I can... My rook should still only move orthogonally. But I don't want like this shouldn't be used with pieces outside of that. So I don't actually need to modify that, but I need to check that it is in fact orthogonal between the two. So I'm gonna do I'm gonna write a helper actually. An is orthogonal is diagonal. Public static bool is orthogonal. Int start int end row column row column, and the check becomes what I have here in my rook. Target. Should have named it end because my brain really wants it to be. And then we just return that they in fact equal 1. Alright, so it is orthogonal if they are equal to 1. And then we'll do something similar for is diagonal. And then that's in my bishop here. So I'm going to return this expression here. So if so this expression becomes if it is diagonal. All right, so now in my bishop, I can say if we are not diagonal, start target, return false. And my bishop becomes if utils dot is orthogonal, start target. If it's not, return false. All right, let's see if I broke everything. All right, I have some confidence there. I didn't see it light up with all X's everywhere, so I'm feeling okay about that. And then in game state itself, we're gonna say if is utils dot is diagonal start target. So if it's not diagonal and it is not orthogonal, return false. See if we broke it there. So we're saying that you can't check a path that is not orthogonal or diagonal because it's like a weird jumping thing. So let's see if this still works. So one thing that I don't like about this is that I do end up running this check essentially twice. In my bishop and in my rook, but I'm kind of okay with it. I don't need this little comment here and this comment here, so I am happy with how simple my rook and my bishop logic are now. So I'm gonna add this here: git commit -m refactor abstract is path clear. Add is path clear method to game state, which checks if a path is clear if an orthogonal or diagonal path is clear. So what's going to be nice about this is I can reuse this in my queen, right? So my queen logic is like quite complex. And so my goal here is to shrink this down. And so my queen, I actually, the sublogic for the queen, I think literally becomes is path game state, this dot game state dot is path clear from my start to my target, because for checking if the path is clear, it checks first, it has to be just orthogonal or just diagonal, and then checks if it's clear. So doing my queen becomes really simple, saying that I just seems to be working. Let's go move my queen out, because I don't think I did any illegal moves with my queen, so it's possible, because I haven't, my test is not check where the queen can go, and instead is only checking if the moves that I told it to make are valid. But I'm getting excited with this. So let's get my queen out, p4 to d4, and then the queen on the other side. Let's do p5 to e5, q1. It's looking good. Let's move my queen down to b4, and let's move this queen up to g, what is that, 5, and then q1. Yeah. Let's do that again. q1 shows you all the places you can go. I like it. Okay. So we've really simplified all of these pieces. Look how simple, except don't click on pawn. Pawn is not simple. All of these have really been reduced quite a bit. And even our abstract piece is short, 96 lines. With some helpers and stuff in there. I'm really digging this. I'm really happy with how this is going. All right, get status, get add. We'll add my queen piece. Get commit -m refactor simplify queen piece logic. Okay. I know I said I was going to take a break, but I really want to see if I can tackle the pawn piece next and get it done and be done with all my piece refactors here. So if I can do that, this is the last one that's referencing my board layout, and I think I can remove it. I can get rid of that global variable, and that would make me very happy. So we're gonna see if we can finish this real quick here. So I'm gonna rewrite my pawn logic, and we're gonna do some simple pawn logic. We're not gonna include the in passing, because I don't think that's included here anyway. But we're gonna do the logic here that says if the piece, all right, so pawn can move 2 spaces if it is in its starting position, and it can move diagonally if there's an enemy piece diagonally in front of it. Okay, so the possible moves are, depends on the direction you're going. So there's is a check here that says, what color am I? So if, and I kind of hate it. All right, I'm gonna do int row increment. So the direction we move is up or down. It's going to be based on whether or not we're a blue piece. So if this dot color is blue, that means we're incrementing row to move down. All right, 1, otherwise -1. All right, 1 or -1. All right, so then we want to say if, all right, so normally I only want to be able to move one position. So let's see here, int column difference is going to be math. I don't actually want to do math. I just want to do start.column minus target.column. Is that right? So this is going to tell me if I'm moving diagonally. All right. So here we go. Bool is attack. So I am an attack if I'm moving diagonally. So if my column changes, that means I'm trying to do an attack. So bool is first move if my difference start.row minus target.row if this is a 2. So if the distance I'm moving is 2, it must be I am in a starting position. So we're gonna do if is first move and I'm not in my starting position. Okay, and I'm not in my starting position. So with our pawn piece, and this is also true for castling. I didn't check if castling was possible in this. I don't think castling was possible in the original game. I might have removed that logic. But yeah, castling isn't in here. So that's an interesting thing. I'm gonna have to ask the original. I'm gonna have to go back to the original program and see if I can cast. I don't think I could. So I'm gonna actually add that into my king piece. Yeah, it definitely wasn't here. To do kings can castle if they have not moved yet. All right, so if they have not moved yet, and you move next to your rook swaps spots with you. So there's some magic, so there's this weird to-do thing here that after the refactor, we can add that as a feature. All right. So in my pieces, in my eyepiece, or abstract piece, I don't think I need it in my eyepiece, but I want to be able to determine whether or not a piece has moved. So I'm gonna put an eyepiece, but public bool has moved. All right, so we know whether or not this piece has moved. All right, and then so in our abstract piece, it's gonna tell me I need to add that. So we're gonna add it in here. Private read only, not read only because we have to be able to update it. Bool has moved equals false. Initially we have not moved, but public bool has moved is going to be a reference to our private variable. Get rid of some of this white space here. And then if we move, so when we call move, if we're allowed to move, we actually move this thing. Has moved equals true. So after the piece has moved, we're going to set it equal to true. Okay, so now we should be able to do this here, and I'm a little bit nervous because I've changed stuff outside of this code, outside of this file, and haven't been able to run the test. And I can't run the test now because I've deleted code here, but we're going to say this if okay, actually int row distance is gonna be, I'm just gonna get the row distance like this. Yeah, if row distance is equal to 2, so first off, if it's greater than 2, we return false. Can't move, you can never move more than 2. All right, if the row distance is equal to 2, and this dot, it has moved, and we have moved, return false. All right, so we can only move it twice if we double space if we haven't moved before. So now we know, so at this point it's sort of like moving 2, we need to like make sure the path is clear, right? See, this is why I wanted to avoid the pawn. I felt like the pawn's logic is complex enough. So the idea though is if I get all the way to the end here, I'm gonna return true. So I just need to make all these conditions. All right, so my start row to my target row. This is what my row increment should be. Start row minus. So I think I want it to be like this. Then I'm gonna do a math.absolute here. All right, I can never move more than 2. I can only move 2 if I haven't moved yet. And then I cannot, the path has to be clear, so I can't jump over a piece if this dot game state dot is path clear. So if it's not clear between my start and my target, so this is like a condition where it's only here, right? So I'm gonna return false. So if I cannot, if the path isn't clear, I return false. So this gets basic pawn movements. So it's not actually if path is clear. Oh, so if this is not an attack and the path is clear. So if it's an attack, oh no, the path still has to be clear. All right, the path still has to be clear. I think this will be fine because if it's diagonal, it actually won't check directly next to it. Let's look, we got, what do we got? If we're attacking, yeah, if this dot is, sorry, not this dot, if this is an attack and the board is empty, so this dot game state dot is empty at our target, we can't do that. All right, so we can only attack if it's not empty. Our generic logic check is going to tell us whether or not, our generic logic is going to make sure that we can't attack our own pieces. And then we want to make sure that we're moving in the right direction. Okay. So correct direction would be, we want to make sure that row distance and row increment have the same sign. So if start, so let's make sure that's true. Start row minus target row. So if I'm in row 2 and I want to move to row 3, 2 minus 3 is -1, but I actually want to increment, so it should be target row minus. Target row minus. It's greater than 2, we fail. If it's equal to 2, we can't move into the same spot. On logic is tough. It's too much. Pawns are the craziest pieces in chess. They have the most rules. So if it is an attack, if it is an attack, all right, we're gonna get a little bit tacky and weird here. If it is an attack, then hang on. If it is an attack, we have to be going, and it's empty. But also, if it is an attack, if is attack and math.absolute row distance is not equal to 1, return false. So we can't attack on our first 2 and forward 2 and over 1. Man, this is interesting. All right, so I really. All right, I'm gonna go. This is getting too complex for me to think through. I really want to just say, okay, my possible moves happen to be the ones that from my start I increase. All right, so int target row should be equals start.row plus row inc. So under normal conditions, my target row and my target row should be my target.row should equal target row under normal conditions. So I'm going to say if target.row equals target row and start.column is equal to target.column, return true. But I also can't take pieces. Pawns can only take pieces diagonally. Ugh, this is maddening. Yeah. So I'm wondering if I can do something clever to make this logic nice. Target.row equals, so I can only move in the direction I'm supposed to. All right, target row int first turn target row start.row plus 2 times row increment, and then int attack columns. So there's 2 possible attack columns. Make this left and right. Attack target calls is equal to target dot column -1, so to the left, and target column +1 to the right. So we can go left or we can go right. And then bool is attack is equal to start.call minus target.call not equal to 0 actually. So it's an attack It's not equal to 0. All right, so if it is an attack, then we want to, okay. So we have some checks. So the thing I want to do, on first turn, pawn may, let's do always. Pawn may move forward 1 if space is empty. So let's do that. If target.row is equal to target row. All right. So we're allowed to move 1. And this is not an attack. All right, so that's saying that our column hasn't changed. And this dot game state dot is empty target. Return true. So the pawn can always move forward 1 if it's empty. If our target, if we're moving just in the direction that we're allowed to move and it's an empty space, then we can return true. So the pawn can always move forward. On first turn, pawn may move forward 2 spaces if empty. So both those spaces have to be empty. So if target.row is equal to first turn target row, and it is not an attack, so we can't go diagonal, like can't change our column, and this dot game state dot is empty target, and this dot game state dot is path, I'm just gonna do is path clear, way overkill from our start to target. I hate this, return true. So we're allowed to make this move if we have not this dot has moved. And all right, so if we have not moved and all of these things are also true, to move forward. Okay. Can move diagonal 1 if an enemy is in that space. So if target dot row is equal to target row and it is an attack, so if it is an attack, our target column has to be 1 less or 1 greater, and target calls yeah, let's make this do in array. Is there a contains target dot column? Okay. So if we have moved forward 1, we are attacking, and we have moved left or right, and this dot game state dot is has to be not empty target, return true. So we can capture a piece if we're moving diagonally and forward 1 and diagonal 1. So this here is checking if we're moving left or right exactly 1. This is checking that we've moved in our allowed direction exactly 1. This checks that we I don't need that. I can just check that if we move forward one and we're moving diagonally one and the space is not empty, we can return true. We already have a check in our generic logic that doesn't allow us to take our own pieces. All right, so otherwise, these are the things that, you know, so we can move forward one, move forward two on our first turn, we can move diagonally, and then otherwise we're false, and then there's one other check, weird in to do. Let's see what, I think it's en passant chess. Yeah. To do en passant move. So there's this thing where if your pawn actually jumps past another pawn, they have an opportunity to claim that pawn. So there's some weird thing we're gonna have to do there. All right, I think I'm a little, my brain's a little tired. I'm not too tired, but let's try this. It is letting me move pawns. All right, so I didn't break the generic. Whew, pawn logic. That's why I was gonna take a break. It's okay. Just melt my brain a little bit. Oh no! There's a bug. There's a bug. Looks like there's a bug. All right, let's try. Manually expose the bug. Looks like maybe I wasn't able to. Looks like my attack logic is wrong. Oh, didn't want to do that. I want to do just a regular. P1. Well, let's get it. Let's P2 to B4, P3 to C5, P2. Yeah. Right, so P2. My taking a piece logic is wrong. Let's go to my pawn piece. If going to my target row and my target calls contains, and all right, well let's see what happens. This will mean that I can move diagonally. All right, let's try that. So I can move into the three spaces in front of me. Let's try P2. So something's wrong with that here. All right. Let's try if target column is equal to. Oh, I know. This should be start. So from the start, I can go left or right. One. Let's try that. Two. There we go. All right, and this dot game state is not empty in our target. So our target has to have an enemy in it. P2 goes to B4, P3 goes to C5, P2 can't take that piece now, goes to C5, P4 goes to D, let's not do that, let's go back, P5 goes to E5, P2, yeah, P2 to C6, P4, cool, P to C6, okay. Let's do, and this is why we have that test. I'd be like, how would I possibly test all these things manually without like, be really hard to test them. This gives me some confidence that my logic is working here. Yeah, and so then there's like a bunch of other things we got to do when the pawn gets to the end. All right, but I am happy with this. Here we've got our get status, get add. What did I change in all of these things? Let's look at my diffs real quick. Abstract piece, got rid of some lines. I added has moved. That one makes sense. My I piece, I added has moved. King piece. Oh, I added a note that I need to do the castling, and then I simplified my pawn. As much as I dislike how complex my pawn feels, it used to be much more complex. So it's all about managing complexity. How can we manage the complexity? Make it easier to read, easier to look at. I think these if statements are like much easier to read and understand compared to what was there before. Not that they were impossible. Obviously they worked. Refactor, simplify pawn piece. Okay. I have just simplified all of my pieces. None of them should use program dot inside of them. Program dot. Except for abstract piece, which is using program dot changes. What was I? Yeah, but these are now not using those. The only reason this one's using program dot changes is so that it can update that information. These are all much simpler. So in my game state, not my game state, sorry, my program, it's like, are these being used? Where's this being used? It's used in program for initializing, is also used in abstract piece for some stuff. Not this one. This one's used all over program. A little bit in there. What about board layout? All right, we're getting close. We're getting close. Address list for fill board addresses. Okay, we're getting close to being able to eliminate these. I'm almost to the point. I'm at a point where I can actually feel like my game state. My game state is actually managing. It's keeping track of where all the pieces are, so I could use this to draw the screen, to update the board screen, which is exciting. I mean, I think that's, I don't know exactly what I'm gonna do next, but I'm gonna take a break. Probably won't be back. I've been going for almost 4 hours here, but I'm gonna stop. And if you watched all of this, wow. Have a beautiful day. Have a beautiful week.